This is, well, it's not, it is a real example, but it's not something that how this class is calculated, so don't apply it to this class even though it says Miss Terry. This is another average problem. However, this is an example of what's called a weighted average. Okay, and so this is not going to be set up the same as the last two average problems. The last two average problems assumed that each test had equal weights. Okay, this weighted average, though, it's not, we're not going to just add the test up and divide by 2. And this is actually how your grades are calculated here at All Saints. So this is a good example to have. It says Miss Terry counts her midterm as 2/3 of the grade. So what that means is whatever her midterm grade is, it's weighted at 2/3 the amount. Her final is weighted as 1/3 of the grade. So do you see how it's an uneven amount that's weighted? Okay, more of the grade goes to the midterm instead of the final. It says Mark scored only 64 on his midterm. What range of scores on the final exam would put Mark's average between 70 and 79 inclusive? So let's first define our variable. X would be what? Look at our question. What range of scores on the final exam? So score, and then I'm going to put a final exam. Very good. And then what range of scores would put Mark's average between 70 and 79 inclusive? So those are my two values. Okay, I want to be greater than 70. So whatever's here in the middle has to be greater than, but less than or equal to 79. Okay, and we know that it's the equal to because of this word inclusive. So let's think of how the inside of this would be set up. Since this is not a straight average, we can't just add the two grades together and divide by 2. What would 2/3 of the midterm grade look like? And keep in mind, he made a 64 on his midterm. How would I represent 2/3 of that grade? So 2/3 times 64. Perfect. Okay. And then plus, we know that the final exam counts as 1/3 of the grade. So how do I represent 1/3 of the final exam? So 1/3 x. Perfect. Very good. So this is your equation that you would get credit for. Now let's simplify and solve and find out what x is. Okay, does this involve a fraction? Yes, so let's clear the fraction. Now, to clear this, I'm going to suggest, because if you were to type this entire thing into the calculator, you'd get a decimal, and I don't want you to work with decimals here. Leave it in a fraction form. I'm going to simplify this one step even further. I'm going to figure out what 2 times 64 is, and that is 128, and I'm going to put that over 3. 1 times x, I'm going to put that over 3 as well. And by doing this, it makes clearing the fraction just a little bit easier. What's the common denominator here? 3. So multiply every term by 3. Okay. 3 times 70 is what? And if you don't know how to do this in your head, what's 3 times 7? 21, right? So add the 0. This is 210. Is less than or equal to. The 3's here cancel. So I'm left with 128 plus the 3's here cancel. I'm left with x less than or equal to, what's 3 times 79? Now I don't know that one in my head. You get 237. Okay, and reminder, I'll probably have you use your calculator on the word problems here. Okay, to get x by itself, what do we do? Subtract 128. Now remember, you're doing this from all 3 sides because you have a compact statement. So, cancels out in the middle, leaving us with x. The signs just come down. Now all we do is subtract these. So, 210 minus 128 is 82. 237 minus 128 is 109. Okay, and that's okay to have that a part of your answer, even though most likely it'll stop at 100. So Mark would need to make between 82 and 109 inclusive. And we can leave it there.